Today's video. In this video, we will be talking about abstract data types in Java. So primarily, before we proceed into abstract data types, we have to know what is basically a type or a data type. And finally, we will discuss more on abstract data types. So to begin with, a type is basically a collection of values. Now values could be anything. For example, if we know a boolean type or an integer type, so they are also certain values. Boolean type as in if we have true or false values, then also it works. So this collection of values, basically they correspond to a particular value, or this collection of values, they correspond to a particular type. Now from the type, what we can derive is a data type. Now this data type is a type together with the collection of operations to manipulate the type. Now suppose we have an integer variable. Now that is basically a member of the integer data type, and we can have several operations with that particular data type, like maybe an addition or a subtraction or such type. So we have a type which are values, a data type which is the value along with the collection of operations in order to manipulate that particular value. So these are the two separate concepts which gave rise to the primary concept of discussion today, or primary topic of discussion today, which is abstract data type. Now, an abstract data type is the specification of a data type within some programming language which is independent of an implementation. That means if we are considering a data type within some or implementing the data type within some programming language, however, we do not know exactly how it is implemented, or the back end of the implementation. So at that particular point of time, we can consider that data type to be an abstract data type. So it is hidden, the details, implementation details are basically hidden from the user, or it is encapsulated from the user. The interface for the ADT is defined in terms of a type and a set of operations on that type. So through what type of interface we are going to operate, or we are going to manipulate, or we are going to implement that ADT, that is defined, and it is defined in terms of the type that we are going to handle and the set of operations on that type or on that value. And the behavior of each operation is determined by its inputs and outputs. Suppose we are giving integer values, the operations would be done on integers, and we will get the output as integers. Likewise, if we are working with floating point numbers, or we are working with strings or characters, similarly the output would be generated which is relevant to that operation and to that particular input. Now an ADT does not specify how the data type is implemented. Okay, so though we are using it, or we are performing the operations using some programming language, but this abstract data type will not specify how that particular data type is implemented. This implementation details are hidden from the user of ADT and protected from outside access, which we have already discussed in a concept known as encapsulation. So everything is encapsulated. Okay, so we basically, suppose, let me give you an example. Suppose we know about stack. So if we know that stack follows last in first out strategy, okay, we know only up till that much, and we have certain pointers to that particular stack, but how it is basically implemented in the backend, that is hidden from us, that we do not know. So there is a clear demarcation between the various public functions, private functions, as well as the data structures and how they are stored in the memory. Okay, all of these basically constitute the abstract data type, and this abstract data type, they are accessible from the application program, that means from the user level program, with the help of a interface. And this interface will be primarily focusing on very non-vital parts of the program which do not have, which through which the user will not be able to know what kind of functions or what kind of data structures is that abstract data type capable of performing. Okay, so abstract data type, it is entirely hidden, or the implementation details are entirely hidden from the application program. What user can see is only this application program and nothing else, and this application program will interact with the abstract data type through a interface. Okay, so talking about the types and operations of Java abstract data type, now we can classify classify the abstract data types either as built-in or user defined, or as mutable or immutable. Now sometimes we can create these abstract data types, sometimes we get built-in packages in Java regarding these abstract data types, and we can also categorize them as mutable and immutable. Now an abstract data type is mutable when we can change the objects of its type, and if it is immutable we cannot change its object. Now taking mutable or immutable into consideration, we will have to understand that uh, the date class, okay, here it is mentioned the date class. So date class is mutable because we can set month method, so where we can set the month in this particular method and observe the change with the get month. That means if when we are getting when we are reading that particular month value or month name, so that is entirely different. Okay, it can go on changing. That means for at one time I can set month to, let's say, January, and I can read it as January. Second, in the next moment itself I can consider this method to have February. If I change it to February, then that entire method value or the object would change into February, and I can read it as February. However, string is immutable because its operations do not change the existing objects, but it will create string objects. So when we were doing SCP, string constant pool, we understood that whenever we are creating a string object in the heap memory, there is a string literal pool or string constant pool, SCP. So there also an object is created, as well as in heap memory also the object is created. Now whenever we are trying to change the value of that particular object, or we are changing let's say we have string as Java and I want to change it to C++. So whenever I'm changing that same string value as C++, the already existing original string object will not change. Okay, the original Java object will still be there, but a new object which is C++ would be created. So it is immutable. That means it cannot be changed, or it does not change. Instead of changing, it is simply updating, or it is simply adding a new object with the updated value. However, as far as date class, so in this class we have set month and get month method, and in this class we can go on changing the objects whenever and whichever way we like. Okay, so this abstract data types are either mutable or immutable. That means we can either change the objects, or we can or let's say we cannot change the objects. Talking about the different operations of ADT. So the operations of abstract data type, so there are 4 different operations. One is known as the creator, second one is the producer, the third one is the observer, and the fourth one is the mutator. So creators basically create new objects of the type, that means of the value whatever we are suggesting. So it will create new objects. A creator may take an object as an argument, but not an object of the type being constructed. The next one is the producer. So producers create new objects from old objects of the type, and the concat method of string, for example, is a producer. So basically using the concat method, we can use the old objects as well as new objects. So it takes two strings and produce a new one representing their concatenation. Observers are the third operations associated with abstract data type, and they take objects of abstract type and return objects of different type. The size method of list, for example, it will return an int. Okay, it will generally give you a different output, but it takes objects of the abstract type and it will return the objects of a different type. Now mutators are the fourth operation, and they will change the objects. Basically, the add method of the list, for example, it mutates the list by adding an element to the end. So these four operations basically are associated with abstract data type and types, and we generally play around, or we generally use these type of operations on abstract data types. Now, talking about abstract data type implementation, we have to strictly follow on a data structure which basically deals with the implementation for an abstract data type. In an object-oriented language like Java, an abstract data type and its implementation together make up a class. So we have already talked about class in all our previous sessions. So whenever we are talking about a class, it is essentially an abstract data type together with the implementation. Now implementation primarily focuses on the data structure that it is going to use. So abstract data type along with the data structure, it will basically make up the class. Each operation associated with abstract data type is implemented by a member, function or method. So this we have already seen in most of our programs, that whatever operation we have to do, generally either we are creating an object of it or we are creating a method or a function of it, so that that particular operation is implemented. The variables that define the space required by data item are referred to as data members. So whatever is occupying, it might be an object, it might be a variable, it might be a value. So whatever it is occupying a memory in a space in the memory, it is referred to as data members. And an object is the instance of a class, that is something that is created and takes up storage during the execution of the program. So this one we already know about it. We have been doing objects since the very first session. So it is created and it also takes up storage. So all these things are associated with abstract data type because ADT along with its implementation, that means its data structure, it builds up a class. Now we can consider abstract data type in Java is useful in the implementation of data structures. There are various types of abstract data types which the Java library facilitates us with, such as we have list, we have stack, queue, set, map. These are inbuilt interfaces which we can implement during various data structures. For example, we have already done stack, we have done queue, and we also know about lists, and we also know about set, map. All those things, they are already inbuilt. Okay, so we can also make a user defined abstract data type, but that will depend on the usage, or that will depend on what type of problem we are associating us with. But essentially we have already inbuilt abstract data types in Java, which helps us to do things in a much more sorted manner. Now talking about Java ADT, so I have already mentioned that we have several inbuilt abstract data types in our Java library, like list, stack, queue, set, map, and these are inbuilt interfaces. Now this abstract data types, basically whichever there is in the Java library, or whatever we would be creating as a user defined abstract data type, it will extend the collections interface. There is a collection interface which will represent the data type, and it is a part of Java collections framework and is the root interface in the collection hierarchy. There is a hierarchy which is maintained by Java library, and this hierarchy basically is known as the Java collections framework, and this Java collections framework is implemented or is extended by the abstract data types. Now like we say that all the classes, they basically extend the object class. So here also these abstract data types, they will be extending the Java collections framework, and basically a collection represents a group of objects which is known as its elements. Moreover, the JDK does not provide any direct implementation of this interface. It provides implementation of more specific sub-interfaces like list and set. So the sub-interfaces like lists and sets as well as maps, so these are basically provided by these implementations are basically provided by the JDK, and this interface is typically used to pass collections around and manipulate them where maximum generality is desired. So we can make use of this interface in different classes at different possible functionalities, so that it will provide us with the maximum generalization. Okay, we do not have to have any specific cases, because if we have any specific cases, it will again increase the complexity of the program. So since we already have an interface and we have a collections framework, so this can be extended whenever and wherever it is necessary. Now talking about one of the primary abstract data types of Java library, which is the list ADT. So list abstract data type, it is a collection of elements which have a linear relationship with each other. By linear relationship, what we mean to say is that except for the first one, each element on the list has a unique successor. Also, lists have a property intuitively which is known as size, because if we have a list, definitely it will have a size, which is simply the number of elements which is present on the list, or which will be there in the list. And this list is mutable. That means the objects can be changed. So list is also an interface, which means that other class provide actual implementation of the data type. So this list interface, it is basically extended by other classes, and there we can find out the actual implementation of the data type. Now we must have heard about a concept which is known as a class which is known as array list. An array list, basically it is a ADT of the list ADT, which is implemented internally using the arrays and linked list, and it is implemented using the linked list data structure. So this is a special combination of arrays and linked list, and this basically you can go on changing its object the way we feel like. Okay, so it is mutable. It is not that we cannot change this. Definitely we can change whatever type of array we need, or whatever type of linked list we need. So the operations of the list ADT can be classified as, so there were 4 operations we discussed which primarily works with ADT. So creators, which is primarily responsible for creating the objects, are basically java.util.arraylist and java.util.linkedlist. So these are packages which will help in creating the constructors as well as the objects. And the next one is the producers. So producers, basically we can find it in collections.unmodifiable list. So these are some of the different methods, or these are some of the different packages which are under this operations, which helps us to easily do the operations. Okay, then observers again, size method of java.util.arraylist, that get index method of java.util.arraylist. So these are the observers. And mutators, so they will be used to add or remove an element. So these are some of the methods which are already there in the java.util.arraylist. So list ADT, basically it specifies 25 different types of operations or methods, and these are just some of them. Okay, like get int index, it returns an element at a particular index from the list. add appends the specified element to the end of the list, then remove object, so it will remove the first occurrence of the specified element from the list, then remove int index, it removes the element at the specified index from the list, then size, it returns number of elements of the list, is empty, it returns true if the list is empty, otherwise it will return false. So these are just some of the operations among 25 operations which are there in Java libraries list interface, and we can incorporate this list interface using the array list or the linked list packages in Java. Talking about the next commonly used ADT, which is the stack ADT. So as all of us know, stack follows a last in first out data structure where similar elements are arranged in a ordered sequence, and all the operations in the stack will take place at the top of the stack. So they basically, stack is a collection of homogeneous data items in which all insertions and deletions occur at the end, which we have already mentioned that at the top of the stack all the operations would be taking place at the top of the stack, because that is the first element to be popped out. So we whatever we know is just about that stack abstract data type is that there is a pointer to the data, and instead of storing the data at each of the node, we will simply point to that particular data using this pointer, and the program allocates the memory for data and passes the address to the stack ADT. Okay, the start node and the data nodes encapsulate together in the ADT. Only the pointer to the stack is visible to the calling function. That means from application point of view, what we can see is only the pointer to the stack. Otherwise, all the data nodes are encapsulated, that means hidden from the application program. The stack head structure also contains a pointer to the top of the stack and also the count of number of entries which are currently in the stack. So this is what the stack head structure does. So all of these things which are mentioned, all of these points which are mentioned here, okay, so they are basically showing us that stack is already an ADT which is present in the Java library, and what is known to us is just that whatever operations will take place is on the top of the stack, and there is a pointer. It does not have any memory also for storing the data at each of the node, so it will just point to the data. It will just use a pointer to the data. Now the program will allocate some memory for the data and passes the address to the stack ADT. So the memory is provided for the data, but it is not provided to the abstract data type. Okay, it will just pass the address to the stack ADT, and we can do the operations on the stack ADT using the different methods of the java.util.stack. So creators, basically we have java.util.stack constructors, then producers we have vectors, vector methods of vector, observers there is a peek method, then is empty method which is there in java.util.stack, mutators there is a push item method of java.util.stack or the pop method of java.util.stack. Now there are various operations which are there in this particular library or this particular package. So these are some of them where we have push, pop, peek, size, is empty, is full, and these are some of the operations which are most commonly used in the stack ADT. Okay, so basically we will use this stack ADT in order to implement any data structure operations which requires this kind of operations. Now the third and one of the very commonly used ADT is again queue. So it is a collection of elements, homogeneous elements which are arranged sequentially, and it follows the first in first out structure. The operations can be performed at both ends with insertion being done at rear end deletion being done at the front end for a single ended queue. So we know that there are several types of queues which are there, but for a single ended queue, both the ends, unlike stack the operations happen only at the top of the stack, whereas in queue, at both the ends the operations would be taking place. Okay, and in case of a single ended queue, insertion would be done at the rear end and deletion would be done at the front end. That means the first element to go in can be removed or deleted in the very first place. Okay, it will be the first element to be deleted as well. And generally linked list, or if we are having an array blocking queue, they implement the queue ADT using linked list and array lists internally respectively. Okay, so operations, different types of operations are there. So as already mentioned, queue basically is implemented by the linked list. So we have creators where we use java.util.linkedList constructors, linked list package constructors. We have producers, so then we have observers, there is a peek method. We have mutators, which adds where it is mentioned add e item, that means it is a method in the linked list queue ADT where you can add an element. So these are some of the operations which are done using the java.util.queue ADT or package. So here enqueue is a method, dq is a method, peek, size, is empty, is full. So all these operations, so they are used to do different types of they have different types of functionalities associated with the addition and removal of an element in a queue. Okay, or in a because we are considering queue as a list only, so basically it is a we are placing them sequentially, homogeneous elements which we are placing them sequentially. So all of this, they have some of the methods in common, because all these operations can be done using all the three different ADTs. Now talking about which Java ADT do we choose. Now suppose if we are considering a list ADT. So if we are considering a list ADT, it is a collection of elements which are stored sequentially and we can be accessed using indices. So we use different index in order to access the elements of the list ADT. It needs to be chosen in cases which involve sequential or indexed access or removal of elements. Now for example, if we want to store a list of students in a sorted order for an ordered or an indexed access or removal of that particular student list, we have a number of students in a class and we want to store them in a sequential manner, roll number wise. Okay, and we want to remove them also using the different roll numbers. So at that point of time we can use the list ADT. Now when can we use this stack ADT? So suppose, because we know stack has the last in first out data structure, or it follows that particular process, we have to choose those scenarios where the most recently inserted elements need to be accessible first. Okay, so one of the very common example is there, that means it is required when there is a function called stack of every programming language, where the most recent function in the stack needs to be executed first. So there are number of functions which are there in your program, or number of methods which are there in a program, and now whatever is the most recent, or whatever you have entered into that particular stack, we have to execute them one by one, or in the last in first out strategy. So at that point of time we can use stack. Now queue we can use in the service handling by the web servers. So whenever we are using a web servers, these web servers, they facilitate the fairness of request handling according to the order of arrival by maintaining an internal queue for the request. Okay, so suppose we are sending several requests to a server from different machines, so whichever request is received first, that would be served first. Okay, so web servers, they generally follow a queue. Stack on the other hand is following a different concept, which is if there is a LIFO data structure, not LIFO data structure, this kind of data structure would be required in the function call stack. There is a function call stack. We will do about this in every programming language, and there the most recent function in the stack needs to be executed first. That means whatever is present on the top of the stack, that would be executed in the first place. Okay, so this is how we can choose what type of abstract data types we need in order to execute the scenario. Now, designing an abstract data type in Java, we talked about inbuilt data types and user defined data types. So inbuilt data types, we already have seen 3 of them, which is the list, stack, and queue. So in order to design an abstract data type, suppose we want to go for an user defined data type, we have to choose good operations and determine how they should behave. So there are certain rules for designing this ADT. So it is better to combine simple and few operations in powerful ways rather than a lot of complex operations. So this should be kept in mind. Each operation in the ADT should have a clear purpose and should have logical behavior rather than range of special cases. We generally go for more generality instead of speciality, and all the special cases would make operation difficult to understand and use, and it will increase the complexity. And that is why we have to have a more logical approach while designing the ADTs. Okay, we should make sure that there are no special cases or minimum special cases. The set of operations should be adequate so that there are enough kinds of computations that users likely want to do. So like there are 25 different operations. If we want more operations, we have to define all of them. So the type may be either generic, for example a graph, list, or set, or maybe domain specific, for example an employee database, a street map, a phone book, etc. But there should not be a combination of generic and domain specific features. So we might go ahead with a structure, or we might go ahead with a specific structure or a generic structure, but we have to make sure that there is no combination between both of them, because otherwise it will create an ambiguity. So basically what we saw in an abstract data type is it is a collection of elements, collection of different types of members, collection of different data types along with the operations and the data structures which are involved in it, and we can make use of this abstract data type as and when we need based on the scenarios that is needed. So this is all about abstract data type and what some of the examples which are there already in Java library. We will make use of them in our subsequent sessions in different programs that we will be doing. So that is all for today's session. In next session we will discuss more on this. Thank you.